Greetings all of you, my name is teacher Junju Isaac, and in this video we can see that there is another set of logarithmic equation which we need to solve simultaneously. Now let us start with the first one. We have log base 4 of x minus log base 2 of y equal to 0. So now what we normally do is to eliminate the log in one of the equation if one equation has no log. But now there is some work to be done here because this is log base 4 and the other one is log base 2. Unless you put them at the same base, you can't eliminate it. So let us first change. You can either make this to be term, you convert to log base 2, or you make this term to be log base 4, so that you work with the same base of the log. Now let us see. Let me change this to log base 2. So I'll be having log base 2, now x over log base 2, then I have 4, which is 2 squared, minus log base 2y equal to 0. So this is going to be log base 2 x over 2, because now this 2 will come down and log base 2 of 2 is 1, so we remain with a 2. Then minus log base 2 of y equal to 0. So let me multiply with 2 throughout. This will be log base 2 of x minus 2 log base 2 of y equal to 0. So I have to take this 2 now and y there. So it will be log base 2 of x minus log base 2. Now the 2 which is here will go up, so we get y squared equal to 0. Since it is a minus, we can use the division now. Law of logarithm, so this will be x over y squared equal to 0. This is log base 2. So we can now eliminate the log. So this is a 2, so we shall be having x over y squared equal to, we take this 2, will become the base on the other side. What we find there should be the power. So we can see that we are having x over y squared equal to 1, or x is equal to y squared. So now we come back to our second equation, which is x squared minus 2y squared equal to 8. Since x is y squared, so we can put x here. So we shall have x squared minus 2x equal to 8. I factorize. Now we bring this on this left hand side. So we shall be having x squared minus 2x minus 8 equal to 0. So we can solve this using a quadratic formula. We can complete square or factorize any method of solving a quadratic equation, and we get the answer, the value of x. So factorizing it, x minus 4 times x plus 2 equal to 0. So now here, either x is equal to 4 or x is equal to negative 2, but this is not a solution. According to logarithm, we don't have a log of a negative number, and when you put it here, it will be log base 4 of negative 2, which does not exist. So this one, we leave it, and we move on with x equal to 4. So if we take x equal to 4, we can find y. So y is equal to the square root of x from here. So our y will equal to the square root of 4. So we see that y is equal to 2 or negative 2. But this does not exist because we cannot be having a log of a negative number. So the solution will therefore be x to y. Our x is going to be 4 and our y is 2. So that is the solution for part A. Now we have to do part B. Now let us look at part B. Now we have one equation. It has no log, but we have this one with a log. So let us first get rid of this log. So we shall now get, you see it is log base 10. It is the same base, so we just need to just create left hand side and right hand side, then we equate. So now when we look at this, it will be log of x minus log of 2 power 2 equaling to log of 1 plus y over 2, which is log. Now this is a minus, so we shall divide. So it is going to be x over equaling to log of 1 plus y over 2. Now from here we can now say that x over 4 is equal to 1 plus y over 2. So x will be multiply with 4. We shall have 4 plus, now times 4 here, we get 2y. So x is equal to 4 plus 2y. Now we come back to the other equation now, and we see now the other equation, we have x plus, from the first equation we have x plus y equal to 4 plus root of y squared plus 2. So we can substitute for x because there is only one x here. So let us put that x as 4 plus 2y, then plus y equal to 4 plus the square root of y squared plus 2. Now this 4 go with the 4. We have 3y equal to the square root of y squared plus a 2. So we can square both sides to get rid of this root. So we shall get 9y squared equal to y squared plus a 2. Then when we bring y squared this side, we get 8y squared equal to 2. Okay, so now we have y squared to 2 over 8, which is 1 over 4. If we divide by 8, so our y is equal to the square root over a quarter, which is plus or minus a half, but we cannot have a log of a negative number. Do we have that y? When you put here the negative, it is negative half. Okay, this is 2 plus y over 2. Let us see, plus or minus a half. Let us see. Okay, so let us see. Now since we have the value of y as plus or minus a half, now I'm taking a negative because when I look here I don't have a negative. When you put a negative half here, the log will be positive, because this is going to be 1 minus 0.5 over 2, which is greater than 0. So we shall test if the value is valid. So let us see. If y is a half, what is x? We see that x is equal to 4 plus 2 over 2, which is 5. And we also have x as 4 plus 2 negative a half. So this will give us 4 minus 1, which is 3. So I hope the values are, when y we have x to y, we have two solutions here. There is when x is 3, when y is negative a half, and there is when x is 5, when y is a half. And they are all true simply because there is no value. This negative value of y does not violate the laws of logarithm. We can get the other value for this. So maybe you can test here, try to test the two values if they all agree with the equations, but I hope it is true. So that is it. Let us see part C now, where we have log base 2 and log base x of y. Then you have x, y equal to 16. Take a note, this is log base x of y. So now let us see, since we are solving for x and y, we cannot do that when we have a x as a base, so we can get rid of that by maybe converting this term to another base. And when you look at this is log base 2, let us take this one to be also to base 2. So we are going to say log base 2 of x minus log base 2 of x divided by log base 2. No, the other one is log base 2 of y, the one up here. So it will be log base 2 of y, and this will be log base 2 of x, because it is x and y, and x is the base, so it should be down here. Now equal to 8 over 3. Now I'm going to multiply with log base 2x, so we shall get log squared x, this is log base 2 squared x, then minus log base 2 of y equal to 8 out of 3, so this will be 8 over 3 log base 2 of x. Okay, so now we come back to this second equation. The second equation is having x, y equal to 16, so you can substitute for y such that y is equal to 16 over x. So there we can have log base 2 squared of x minus log of 16 over x equal to 8 out of 3 log base 2 x. So now this is a division, so we can split it and use a minus. So we shall have log base 2 squared of x, then minus, so we shall get log base 2 of 16 minus log base 2 of x equal to 8 over 3 log base 2 of x. So from here I can multiply with 3 throughout such that I get log base 2 squared of x minus 3 log base 2 of 16, and then plus 3, because now this 3 is going to multiply this bracket, so it will be plus 3 because it is minus minus, then log base 2 of x equal to 8 log base 2 of x. Okay, so from here, I hope you can now see that we can collect like terms. We have on log base 2 of x, log base 2 of x, we have 8 log of x, and we have this constant here. Now, since this is base 2, we can now change this one to the powers of 2, and this will be 2 power 4. So this can be 3 log base 2 squared of x, but now we have a 3 log base 2 of x and we have 8 log base 2 of x, so when we take it the other side, it will be 5 log base 2 of x. So when we bring this left side, it will be minus log base 2, not minus, but minus 3, no, minus 5. It is minus 5 log base 2 of x, because this is 3 log base 2 of x and the other one is 8 log base 2 of x. Okay, then minus, now this one here, this can be, if we look at this one here, we can write this as 2 to power 4, 16 to power 4, so we can bring 4 this side and it become a negative 12, such that we remember the log base 2 of 2, which is a 1, so we get negative 12 equal to 0. And now when we look at this, we can let log base 2 of x to be any other letter. Let me call it t. So we shall be having 3t squared minus 5t minus 12 equal to 0. And now we can solve for t using a quadratic formula. So our t will be equal to negative b, which is 5, plus or minus the square root of b squared is 25, now minus 4ac minus 4 then a is like 3, c is negative 12, then divided by 2a, which is 2 times 3, and that is 6. So t will be equal to 5 plus or minus 13, because this is one root of 169, then divided by 6. So we shall get t to be equal to 5 plus 13, which is 18 out of 6, and that is 3. Or t will be equal to 5 minus 13, which is negative 8 over 6, or negative 4 over 3. So now, since we have the value of t, but remember this, that y is 16 over x, and remember that log 2 x is going to be equal to our t. Now let us see. We know that y is equal to 16 over x, and the log base 2 of x is equal to t. So our t has given us 3 and negative 4 over 3. T is 3 or negative 4 over 3. So let us find the value of x. We begin with this. Log base 2 of x is equal to t, and t is 3, so x will be equal to 2 power 3, which is equal to 8. That is x1. Then we also have log base 2 of x equal to negative 0.75, so x can be equal to 2 power negative 0.75. That is the second value of x. So this is not negative 0.74. It is negative 4 over 3. So we shall have x equal to 2 power negative 4 over 3, and from the calc we shall see that this is 0.40. So now, since we know our value of x, we shall see that y is equal to 16 over x. X we have 8, so that is 16 over 8, which is a 2. That is y1, and y2 will be equal to 16 over 0.4, which is giving us 40 approximately. So the solution for these two values, for the values of x, the first one is going to be 8 to 2. Then we also have 0.4 to 40. Let us see part D. And in part D, we have log base 5 of x, then plus 3 log of base 3 of y equal to 7. But now when you have it, when you see this, if this is 3 and this is log of base 3, these two cancels. One is a log, another one is anti-log, so we remain with a y, and therefore we see log base 5 of x plus y equal to 7. Now let us see the second one. We have xy equal to 600, 205. So now what we can do now, we can bring in the log base 5 on both sides so that we drop the power. So when I get log base 5, because I have log base 5 on the first equation, that's why I'm choosing log base 5. So I get x y equal to log base 5 of 625 power 3. So this can be y log base 5 of x equal to 3 log base 5. Now this can be written as 5 to power 4. So we get y log base 5 of x equal to 12, because this one here will come here, 4 will drop, multiply the 3, we get 12. Log base 5 of 5 is 1. So you see that log base 5 of x is 12 over y, and here log base 5 of x is equal to 7 minus y. So we can equate the two. When you look at this, log base 5 of x will be equal to 7 minus y, which is equal to 12 over y. So when I consider this, I cross multiply, then we get 7y minus y squared minus 12 equal to 0, or y squared minus 7y plus 12 equal to 0. And now we can solve for y. And when we factorize, we see that y minus 3 times y minus 4 will be equal to 0. So y1 is 3 and y2 is 4. Then what is x1? x1, when you come back here, we can find x1, or we can use this, because when you look at this, we see that log base 5 of x is equal to 12 over y. So x1, we shall have 5. By the way, when you get 12 divided by y1, you get 4. When I use 3, I will get 4 here. So I'll be having 5 power 4. And x2 will be equal to 5. Now when I use this y2 and I divide it by 12 divided by that, I get 3. Take 5 this side, we shall have 5 power 3. So this gives us 625, and this gives us 125. So x to y, we have two solutions. When x is 2625, y is 3, and when x is 125, y is 4. So now let us look at our last question. Here we have x log y, x to power log y equaling to 2. Now we cannot look for y when it is in a log, power to the log. So let us introduce log base 10 on both sides. So when I get log on both sides, and even here we get log 2. So now this power will drop, and we shall get log y times log x equal to log 2. At least now we have something to start with. Now let us see the second one. Now here I'm seeing x times y equal to 20. I can introduce a log still, so that I separate this. Then I'll be getting log of xy equaling to log of 20. So this is going to be log x plus log y equal to log 20. And now you can see that we can substitute, because here we can find log y in terms of log x, and we substitute, or we can use this equation such that we get either log y or log x. So from the first equation we can see that log y is equal to log 2, and log 2 is 0.3 over log x. And now when you come here, we can now replace this log y here, so we shall be having log x plus 0.3 over log x equaling to, now log 20 is 1.3 on the calculator. So when you multiply with log x squared, you shall log x, you shall get log squared x here, then minus 1.3 log x plus 0.3 equal to 0. So now we can find x from here by letting log of x to be again a letter. I can use t, so t squared minus 1.3t plus 0.3 equal to 0. So we can use a formula to get the solution here. So t will give you 1, or t will give you 0.3 if you substitute in the formula. But what is t? T is log x. So log x is equal to 1, or log x equal to 0.3. So x is going to be 10 to power 1, that is x1, and x2 will be 10 to power 0.3. So x1 is 10 and x2 will be equal to, this will be approximately equal to 2. So now we can come and either use this original equation to get the value of y, because we know that y will be 20 over x. So we shall have y1 will be 20 over x1, which is 20 over x1 is 10, which is 2, and y2 will be equal to 20 over x2, which is 20 over 2, and we get 10. So we see that x to y, the solution set, we shall be having 10 to 2, or we shall be having 2 to 10.